Alright, so one more example here about finding the value of a trig function if we're given a little information about some of the values of the other trig functions. So we want to figure out cosine of theta given that tangent of theta is 3 over 7 and also that sine of theta is less than 0. So a couple things here. So the first thing is I'm going to figure out what quadrant that my angle theta is in. So tangent of the angle is positive. Tangent is only positive in quadrant 1, and tangent is also positive for angles that fall in quadrant 3. Alright, well, if you think about sine theta though, okay, this says sine is negative, it's less than 0. Sine is negative in quadrant 3 and also in quadrant 4. Well, the only way to make both of these happen simultaneously, to make tangent positive and to make sine negative, would be for our angle theta to fall. It's got to be in quadrant 3. Okay, so I know that now my angle theta is in quadrant 3, and that means cosine of that angle, well, in quadrant 3 is cosine positive or negative. In quadrant 3, cosine is negative, so I know that cosine of theta has to equal something negative. At this point, the way I do them personally, you can use identities and other things that maybe you haven't seen yet. One thing you can definitely do is just I'm going to make a little right triangle based on tangent. So here's tangent of theta. Okay, so tangent, remember tangent is defined to be the opposite over the adjacent. So that means the opposite side is simply going to be, we can just assume that it has length 3. The adjacent side has length 7. Again, they don't have to be 3 and 7. Maybe it was 30 and 70. Again, the point is the ratio is going to be the same no matter what. We could figure out the missing side using Pythagorean theorem, because remember cosine of an angle, cosine is defined to be the adjacent side over the hypotenuse. Well, again, we know the adjacent side, it's going to be 7. The hypotenuse, again, we can figure out using Pythagorean theorem, so we'll take 7 squared plus 3 squared. We'll call that, let's don't use h, well, let's use h for hypotenuse, equals h squared. Well, that's 49 plus 9, that's going to be h squared. So that's going to give us 58 equals h squared. So if we take the square root of both sides, again, discarding the negative solution, we'll get that h equals the square root of 58. So that's simply what we can plug into the denominator. A couple things, again, sometimes people will want you to simplify this down, get rid of the radical and simplify. Let's see, so cosine of theta is negative 7. Let's see, can we really simplify the square root of 58? Maybe I'll do that first. Well, let's see, two numbers that multiply to 58 would be 2 and 29. Well, 2 and 29 don't really factor any further. We can't take the square root of either of those, so we really can't simplify the square root of 58 much at all. But to rationalize, we can multiply the numerator and the denominator by the square root of 58, and that would give us our final answer of cosine theta equals negative 7 square roots of 58. In the denominator, we would just be left with 58. Alright, so again, basic thing, usually when I do these, again, whenever I'm given, one of the trig values, I can basically just set up a little right triangle based on that. Then, from, remembering, the relationship of the opposite, adjacent, and hypotenuse to the trig function I'm given, so I can figure out cosine. So again, I knew cosine was adjacent over a hypotenuse. But the last thing I really need to figure out is what angle is my, what quadrant is my angle in, and then I determine the sine based on that. Okay, so the triangle, setting up the triangle doesn't really tell me if things are positive or negative for my the trig function I'm using. So again, I have to think about what quadrant the angle's in, and then I can figure out whether it should be positive or negative.